Hello students, good day. I hope all of you are good and have a basic understanding of the course. I hope you will enjoy it. For today we have boot sequence. Booting is a process that means that how an operating system is loaded onto the RAM from any secondary media like CD-ROM, floppy drive, hard disk. Nowadays we have hard disks are fairly common, so it's usually from hard disk to our RAM. So there are various steps that are involved with it. Uh, Usually we have a bootloader. That is a program that is used to load the operating system from the hard disk to the main memory. So usually when we turn on our machine, we have some very basic checks. So first of all, it checks the bootloader checks whether there is some storage device associated with the system or not, in the form of hard disk, floppy disk. So if something is there, then it's fine. But if it's not there, no floppy drive, no hard disk, no CD-ROM is present, then it displays a message that no boot device is found. This message reflects that either the device is not present or it is not detected by the bootloader. The second, if the device is present, some floppy or some hard disk, some CD device is present, but it is not formatted according to the requirements of the bootloader, then it presents a message that insert system disk. Insert a disk that has system installed in it, means the operating system is not there. So next question can be that if there is no hard drive or there is no permanent storage, then from where these messages are displayed onto the screen. So for example, because you see that these messages have to be stored somewhere. So if we don't have any permanent storage attached with the machine, where these messages are stored, the answer to this is that we have a chip on our motherboard. We call it ROM BIOS. So it's a storage that contains the basic messages, the basic subroutines, the very basic setup that is used to load the operating system onto the RAM so that it can start its processing. And without it, we cannot. If we cannot load the operating system, we cannot further utilize the programs or the subroutines, the services that are associated with it. So all of the initial messages, all of the initial subroutines, they are stored onto a chip on the motherboard. We call it the RAM BIOS. So it has a software that is burned to it. We call that software the firmware. Now, firmware is a software that is actually embedded onto its hardware. So a software that is already embedded onto a hardware is termed as a firmware. So this ROM BIOS contains all of these messages, the basic initial uh, passage through which an operating system is loaded onto the RAM. So first of all, when the machine is switched on, the ROM BIOS, it looks for the subroutine, how this operating system can be loaded onto the RAM. So it has initial program loader. So that is the first program, the very basic bootloader that is responsible that is executed once the machine is turned on, and this program is responsible to load the operating system onto the RAM. So this initial program loader is the first program that is executed whenever machine is turned on, and it checks for the presence of a hard disk or storage device. And then the messages that we have on to a couple of previous slides, that it checks whether the device is present or not. If it is present, it says that if it's not present, it displays a message. If it's not formatted according to the requirements of the system, another message displayed. And if there is no operating system present, then another message is displayed. So all of these messages, all of these subroutines are there so that operating system can be loaded efficiently onto the RAM. Okay, so once this IPL starts its execution, it executes the bootstrap routines. Usually they are stored onto a hard disk, and there is a boot sector of or hard disk that contains the initial information about where this operating system is stored. Usually your hard disk is divided into sectors, tracks. We will talk about these in a bit of detail towards after your mid 2, where we will look into the structure of hard disk and stuff. But for now, this should be sufficient, that a hard disk is divided into various sectors and various tracks. So this boot sector is the first sector of the first track, and the responsibility of this bootstrap routine is that take out the operating system from this boot sector of the hard disk and load it onto the RAM. So it has these basic functionalities. First of all, it finds the operating system kernel. I hope you remember from the previous lecture that kernel is the minimum part of the operating system that has to be resident all the time in the RAM while the machine is switched on. We will look into various types of kernels hopefully in today's class, or maybe in the next chapter I will and then once it finds the operating system minimum set of commands that are present on the hard disk, it loads that section onto your main memory, and then it starts the execution of the operating system. All right. I hope this boot sector stuff is clear to everybody. I know that there are courses where you already have uh, basic understanding of what is booting, what is a boot process, and how it is initiated. But just to make sure that all of us are on the same page, I wanted to put this information here as well in a bit more detail than basic level courses. This detail is also present in a bit more depth in your book as well. So if you have the book, if you have access to the book through the library, or somehow, please read this chapter so you get the basic understanding of how computers work. This is fairly important because for computer sciences, operating system is one of the very core courses, and various concepts that we discuss in this course, they are quite primary to the computer science domain. So make sure that you get this, and if there is any ambiguity after you go through the books, you can always write down to me. I can always share an additional video lecture associated with the confusions that the students may have. Also, uh, if you want to clear something that you feel is individual to you, and there is a concept that you do not want to ask in front of the whole class, you can always write to me and we can have a Zoom session, uh, for during my office hours or whenever suits you best. So we can also have it to discuss your confusions. All right. Then moving on, the next major topic is evolution of operating systems. Uh, you see that operating systems have to change, have to evolve with the passage of time, because machines are moving at a rapid pace. You can see that we had earlier system. In the previous section, I hope you remember that operating system is just a software. It's just a piece of interface that let the users interact with the machine. So when we have any modification in the machine structure, we have new requirements from the user side or application side, then we have to have some modification in the operating system as well. So that is why we have generations of operating systems uh, with the modifications in the machines. For instance, we started back in early 1950s, when we had the earliest systems, and over there we had the very basic operating systems, and it those operating systems, they had some very basic requirements. They don't have the uh, at that time they didn't have this keyboard and mouse, etc. Neither they have any GUI, but usually used punch cards and stuff for the input. And then we moved on to simple batch systems. We have multi-program batch systems. Moving in 1970s, when we had a bit of industrialization, and this computer was started using in industries. So we were required to have systems or operating systems that can work with time sharing and real-time systems. In the early 80s, we had personal computers, so we required operating systems for them. Then we have multi-processor systems, and then at towards 1990s or late 80s, we had distributed systems, and in 1990s we started to have handheld devices. If you even look today, or desktop computers that were very common there in the last couple of decades. Now they are just there for your labs, and all of you may have your own laptops. So the operating system for this kind of machines, they are required to have much more utilization, much more depth than the original than the initial ones. And now if you see, you have a lot of different graphical options. And now, as we are still moving on, you can see that we have mobile phones, and we require operating system for mobiles as well. I have a section for Android operating systems, and I will share it with you after a while. So here are some of the basic or most common operating systems that are present today in the market. So you can see we have Microsoft Windows, we have Linux in there, we have Mac in here, Symbian. I hope you remember that these were the operating systems that were initialized, that were provided for the earlier mobile devices. Then now we have Android. And if you see, here's the BSD I was talking about in the previous lecture. Uh, this was uh, uh, this was developed by Berkeley University, and they provided the whole documentation of this operating system as well. I utilized it when I was having this course in advanced form back in my MS with the name Advanced Operating System, and over there we studied this operating system, and we went through the whole book and various subroutines that are present in there. So this can be a very good reference for you if you want to look deeper into how an operating system works. If we look at the operating system at from a higher view, we see that there are various important uh, classes of operating systems. Like we have real-time operating systems. These operating systems, they are classified with respect to the control they provide, with respect to the applications they provide, with respect to the functionalities and services that they work with. So the major types of operating systems are real-time operating systems, single user, single task operating systems. Then we have single user multitask, and then multi-user operating systems. We have distributed operating systems, embedded operating systems, mobile operating systems, and batch operating systems. So if you look at this, real-time operating systems are the ones where you are required to work in real time. For instance, operating systems or softwares uh, that support your uh, driving vehicles, aeroplanes, cars. So they have to work in real time. If you push the brake, the brake pads should be pushed in real time. You can't afford to have even a couple of seconds delay in this kind of operating system. So there are various ways to design this kind of operating system, this kind of softwares, as you will see later on in module 3. In module 3, that you can assign priorities with different processes. So this kind of operating system, they work with priorities, and they define which or how much time is required or how much time is guaranteed before a particular process is executed. That is why they are real time. They return the result in at the very moment, instantly. Or another way of looking at it, or another definition of this real time operating system, can be that they guarantee a certain timeline before which they have to or they must return the result. The next type is single user, single task. They are the machines that were used when we had personal computers. So with the you can see that with the when we had uh, big machines that can uh, but that can work a lot for a single user, but still they they cannot accommodate more than one users or more than one process. uh, Over there we had machines which were single users and single tasks, mean that they cannot work with two users or two tasks simultaneously. Now, I hope if some of you is familiar with Microsoft DOS, that was a single user, single task operating system. That you can see that if it's installed on one machine, it can be an example of single user, single task, where you cannot run multiple applications simultaneously on one machine. Then when the capacity or capabilities of these machines, the hardware, they enhanced, and we had more heavy machines. which can accommodate more tasks or multiple tasks simultaneously, we moved to single user multitasking operating system, where the user was one, but there were multiple processes running in the system simultaneously. Now, for example, if you look at your operating system right now, you can be listening to music, working on a browser, develop in some development environment, or for example, Microsoft Word or Excel or anything else. All of them are executed in parallel. So this is a single user multitasking operating system where the user can be single, but there can be multiple tasks. Again, for this type of operating system, we have scheduling, we have multiple time slots for each of the process, which you will definitely uh, look in depth in module 3. It's all about how processes are handled, and over there you will see how you can design some real-time operating system or multitasking single user operating system. Moving on, we had the multi-user operating system where multiple users work on the same machine. When there is only some difference between these two multitasking systems and multi-user systems. Mm, this will be more clear when we discuss processes in detail. But for now, for operating system, if you are a user or if you are a process, it makes less difference, not very evident or very clear difference between the two. There are some basic parameters that are present in there, but if you can achieve functionality of multitasking operating system, multi-user operating systems are not a for call. Then we moving on, we have the other type of operating system as distributed operating system, which are distributed among multiple devices. You have Windows NT for this, for instance. There are combined resources, there are combined disks, storage, and over there you can define much more uh, parameters compared to multi-user operating system. This distributed is where you can share the resources among the users and the tasks within a group. The next type of operating system is embedded operating system, in which you see the operating system is embedded in the hardware. For example, you have this multimedia. Usually the operating system for this multimedia is multimedia projector is already embedded into it, and you are usually exposed to a simple uh, remote control device which can operate on it, and you don't have any customization possibilities for this kind of operating system. Mm, then we have a mobile operating system. Uh, it We have some earlier versions of mobile operating systems. Then we had Symbian, and now we have Android. All of you must be familiar with it, and they actually have enhanced a lot of utility of handheld devices. You see, for mobile operating systems, you have to have mm, consuming less resources. I hope you remembered it from the previous lecture that utilization of resources is one parameter when we talk about operating systems. So for mobile operating systems, or for the device that you are holding in your hand, mm, the the operating system uh, should be something which consumes resources in a more efficient manner. And then we have to have certain features that have to be embedded in it, or that is supposed to be embedded in it for its easier execution of operations that are installed onto this machine. And then we have the batch operating system. Batch operating system. Uh, I I'm not sure whether you are familiar with this batch word. Uh, in earlier versions of Windows, we usually had a file with the name BAT, batch. We call that batch file. Usually, that file contains multiple instructions, one after the other. And when we execute that file, all of those instructions, they execute one after the other, but without any user involvement. So in batch files, for example, you have multiple commands. You have a command of open a file, copy it, uh, make a directory, and then paste the file onto that directory. So for instance, there are four different commands. Now if you write all of them in a batch file, when you execute that file, all of those four operations, four distinct operations, they are executed one after the other. So in the very same manner, a batch operating system is an operating system where we have a list of operations that are executed one after the other. They are stored together. They are not executed in real time or not at the moment, but they are stored for later processing. Let me give you an example of this. For example, if you have a bank branch nearby, and that in the whole city, that there are like 10 branches of that bank, and in the whole country we have the headquarter that is far away. So the usual architecture of this can be, I mean, there can be multiple different architectures associated with this kind of operations, but just assume that we have this mechanism that whatever transaction you perform during the day, they are stored at the local office. And when towards 12 midnight, uh, all the data from the local branch, they are committed onto the database of the main branch. So if such is the case, you can see that all of the transactions that the local branch executes, they will be stored in their local office, in their own machine, in their own database, or whatever type of system they have. And towards the end of the day, all of the batch is transferred, or executed onto the server side as well. There are several pros and cons in this scenario. I'm not talking about the scenario, I'm not considering that this is the best possible architecture with respect to the banking system. I'm just giving you an example that batch operating systems, they execute operations or commands in a batch fashion. So one after the other at one time. So they keep on storing the command, and they execute all of them at once. So now we have some details about all of those types that we just discussed. Real-time operating systems, so they are used to operate on systems that have some real-time requirement. Usually they are multitasking operating systems, means that multiple tasks are executed at once. Oh, probably there is one thing that you may not grasp at the moment, is what is a task. In operating system terms, a task, usually, I know you know the meaning of it. Task is some operation to perform, some process, some command. But in operating system terms, there is slight difference between a couple of terminologies, and we will discuss them in the coming lecture, probably next module. But for now, you can consider that A task is just one process. So multitasking systems are the ones where we have multiple processes running simultaneously or in parallel. So the main objective is predictable response to events. So this is the basic functionality or the core responsibility of operating system, a real-time operating system, that it promises that that a particular response will be generated in a given time. And so usually they don't have very rich interfaces. However, they are very useful in several domains. So as I have earlier discussed, the single user, single task is an operating system that allows a single user with a single task to work on a machine. So MS-DOS is an example of this single user, single task operating systems. Single user multitask machines are the ones where we have single user, but we have multi tasking support, like your operating system that you may be using right now. It is a single user that because only you are working on it, but multiple tasks can run simultaneously. And then we have multi-user operating system, types of operating systems that allow multiple users to work simultaneously on a single machine. I hope you have experience. There are some libraries around the world where they have one big computer, and the users are only exposed to different interfaces that are associated with it. So you can imagine that kind of system as we have one main computer sitting in the middle, and we have multiple screens, your LCDs or LEDs attached with it. So all of the students are working. Uh, they assume that they are working on their machines. However, all of them are attached to that single machine. They are not required to sit in the same building or same premises, but usually multi-user operating systems have their servers stored somewhere, maybe in an entirely different building, and then all of the users they are attached with this a single machine. So multi-user operating systems, they provide this functionality that multiple users can connect to a single machine simultaneously, and they can perform their tasks as the machine is solely attached or associated to them or allocated to them. Distributed operating systems are used for uh, uh, systems that are distributed in nature, which provide sharing of resources. They can have multiple computers attached with each other, or a shared device that is providing services to all of the users attached with it. So these are distributed. We have already discussed some of them. Distributed computations are carried out on more than one machine. So multiple machines or multiple components, they are connected together to work in collaboration to form a distributed environment. And embedded operating systems, as we discussed earlier, that they are the operating systems that are installed on the hardware. So they are shipped in a package, and definitely they are efficient. They are designed to uh, utilize the their respective hardware in the best possible way. And it is possible when you will finish with this course, and when will you when you will combine the knowledge that you acquired from your computer architecture course and your operating systems course, then you can see, I hope, in a bit more depth that how if you know your hardware uh, prior to designing an operating system, you can write your code in probably the best possible fashion. Uh, so uh, the operating systems for embedded systems, they are shipped with the hardware. They are uh, pretty efficient, and they provide very limited interfaces to the users. And mobile operating systems are the ones uh, which are designed for the mobile devices. As you can easily assume that mobile devices, they have their own set of constraints, they have their own set of applications that are executed on these devices, and the set of resources that they have, uh, they are different than uh, different machines like your laptops, your desktop computers. So mobile operating systems are designed to deal with different types of applications that are usually executed onto a mobile phone, as well as you see different types of interface it provides. Uh, we started with the earlier versions, then we moved on to Symbian operating systems, and then now we have uh, Android operating systems, and you can see there are various versions of Android as well. So one has different capabilities than other. I will try to share the slides for Android operating systems as well, just to make sure that you have some information about the most recent and the most popular operating system nowadays. And then we have operating systems that work in batch processing. Uh, Usually, uh, you can see that users don't have any control over when a process is executed. Rather, user information and input data are collected in advance for future processing. Just like I gave you an example with the banking system, that that can take all the data with itself and keep it and process it at some later time. Usually data is processed in batches in these type of machines, and they have different capabilities, and they have different usages that in contrast to different types of other operating systems. So students, that's all for today. I will try to put Android slides for the next lecture, so that just in the very same go you have that as well. I was planning to deliver that towards the end of the course, so you have a basic understanding about each and everything. However, now I assume that as you are going through different types of operating systems, there is no harm, I believe, that if I introduce you to all set of the Android versions and different capabilities that they have, and different functionalities that they provide. Uh, okay, students, so that is all for today. I hope that you are enjoying it. Again, do not try to keep your book with you, and see if you can if you are reading the book chapters along with the slides as well, along with attending the lectures as well, because it is fairly important that you read the book during the lecture, during the video lecture, or even in class lecture. It is not possible to cover the whole book. So it is always beneficial if you read the book as well. we have a couple of good resources available over the internet as well. uh, Nowadays we have all the books available to you in soft forms. So if you can grab a copy of the recommended textbook or reference book as well, that can be great. So it's better if you read the corresponding chapters as well. Please do write to me if there is any confusion, if you have any question. See you in the next class. Till then, please take good care of yourself. Thank you.